Alright, let's take a look at this in-class substitution, the process. So, we're going to talk about how we use substitution to solve a system of equations. So here's kind of an example. We're given two equations. Okay. The first thing we need to do is make it so that we can actually substitute one equation for the other. So if we take this front equation and they added 3x to both sides, okay, we were able to get that y equals 3x minus 3. So they wanted to get it so we have one variable all by itself. Because when we have one variable by itself, we can take what it's equal to and plug it into our second equation in that variable. So we rewrote that second equation, but instead of the y, we said, hey, guess what? Y is equal to 3x minus 3, meaning they're the same. Y and 3x minus 3 are the same. They're twins. So we can swap out the twins, and the reason we want to do that is because on both of these equations up here, they both have a y and an x. There is no way we can solve that and say x equals this, y equals this. It won't work. Okay? But by substituting in one variable for another in that relationship, now I've got two x's. We can combine x's. So they simplify by distribution, then say, hey, those x's can be combined, and if we subtract 12 from both sides, we get, so we can divide by negative 14, and we get one answer. Okay? And remember, when we're dealing with systems, we're looking for where they intersect. So in this case, at negative 1, that's the x value where they intersect, if we were to graph both of them. Okay? Then once we know one variable, we can go back up to our other equation and say, hey, let's replace this x with the number we know. That's what they did right here. They solved that. They got y. So at negative 6, we know this point right here is where our equations are intersecting. So that's our solution. So when we're dealing with substitution, the first step is we need to get one equation to have one variable alone. Sometimes this is already done. Sometimes we've got to do it. Once we've got it equal to a variable like we did over here, then we're going to take that equation and substitute it for the same variable in the second equation. So they took this piece and said this is equal to y, so we're going to replace this y with that other piece. That was the second step. Then we solve. Okay, so they did all this work, solved and got one variable. That was half of our answer. Then we use that answer, plug it back into that other equation. That gives us the second part of our answer. Then we write it down as a point. So let's take a look at some examples. And remember, the whole point is finding out where they intersect. So if we look at number 1, our first step of taking an equation, getting a variable by itself, it's already been done twice. On all three of these it has, right? We've got y equals something else. Y equals something else. So what we can then do is we pick one of these equations. Okay, say this one, we're going to say, you know what? Let's replace this y with negative 8x minus 9. So instead of that y, I wrote this whole piece down because this second equation told me they're the same. Now we can solve. So I add 8x to both sides. Left with negative 9 equals 1 plus 8 is 9x plus 9. Subtract the 9, and we get negative 18 equals 9x. Divide by 9. We get negative 2 equals x. There's half my answer. That was step 1, step 2, and step 3 right there. Okay, then I take this other equation and say, you know what? I now know that x equals negative 2. So I plug in the negative 2. Negative 8 times negative 2 is positive 16. Subtract 9, and we get 7 for y. There's my second half. So I know my answer is negative 2, positive 7. That's where they intersect. Okay, so let's keep looking. Okay, so same idea on number 2. I can say, okay, y is equal to this 3x minus 5. So let's replace this other y with 3x minus 5. Took this whole y out, replaced it with this 3x minus 5. Now I have two x terms which I can combine when I can't combine an x and a y. and then I can solve, and we get 0, because those cancel out and those cancel out. That canceled out and gave us 11x. Whenever we divide anything by 0, it's 0. So my x value is 0. So if I'm looking at that answer, somewhere on the y-axis it's going to intersect. Okay, to find that y value, we take our equation and say y equals negative 8 times 0 for x minus 5. So we get negative 5 equals y. Okay, so those are the steps. We see if we have an equation that's already been solved for, which if we look at 3, it has. Okay, then I take that second piece that it's equal to, and I'm going to replace the variable that it's equal to with that whole expression, with the idea that I'm trying to get one variable alone. Okay, so our equation is we're equal to one variable. I took it and substituted it in. Substitute for y, that x minus 1, just like on a football team, a soccer team. When you substitute somebody in, you replace one player with another player. But we know they're in the same position because that second equation told us they were equal. Then we can solve. Add 5x. 1x plus 5x is 6x. Minus 1 equals negative 19. Add 1. We get negative 18 equals 6x. Divide by 6. We get x equals negative 3. Without substituting in one variable for another, there's no way I can get this to work. Okay? So there's half my answer. Then I go up to one of my equations and say, hey, I know x is actually negative 3. So now I can simplify for y. I've got my answer, negative 3, negative 4. That's where they intersect. It's where they're the same. Okay? And we just keep doing that same thing. So looking at 4, I've got y equals 8x plus 14. That's a connection. Now in the second equation, I'm going to say, you know what? Instead of y, I'm going to replace that. I'm going to substitute in 8x plus 14. Okay, same equation, negative 4x, negative 4x. 3 times y, 3 times y, except y, because they told us y was equal to 8x plus 14, I replaced it, equals 2, equals 2. Simplify, so negative 4x plus 3 times 8 is 24x. 3 times 14 is 42, equals 2. Negative 4x and 24x would simplify to 20x. Subtract 42. 2 minus 42 is negative 40. Divide by 20. X equals negative 2. Then I go back up to my original equation and say, hey, now I know what x is supposed to be to make this work. So I substitute in negative 2 for x, and now we can solve for y. We actually get negative 2, so my answer, negative 2, negative 2. That's the point on the graph where these two equations intersect. Okay? And that's what we're looking at here. Okay? On number 5, same idea. Y is equal to that whole piece. So in my other equation, I replace the y with that whole piece. Okay? We substitute it in. Then we simplify. Negative 8 times negative 3 is positive 24x. Negative 8 times positive 2 is negative 16. Add the 16 to get that there. We get 32. 2x plus 24x gives us 28x. Oh, I made a mistake. That's supposed to be negative 16, isn't it? Which would make this actually 0. That's better. Gotta catch me on those mistakes. So x equals 0. Go back to that original equation and say, now we know that x is 0, so we get our answer of 0, positive 2. That's where they intersect. Same for number 6. Y equals that whole piece. So in my equation, I replace that y with negative 2x minus 17, because they're the same. So we get negative 2x plus negative 8x minus 4 times 17, is that 8 to 68, equals 2. Those combine to make negative 10x. We add 68 to get 70. We divide by negative 10. We get x equals negative 7. Taking this equation now, we say we now know that x is negative 7, so we simplify. Negative 2 times negative 7, positive 14 minus 17 is negative 3. So y equals negative 3, so my answer, negative 7, negative 3. Alright, now sometimes you have to do that first step, okay, like in 7 and 8. So now I'm going to say, let's take this first, x minus y equals 0. Let's get x by itself. So I'm going to add y to both sides. So I've got x equals y. What does that tell me? It tells me that x and y are the same number. So I can take any one of these and say, let's replace that x with y, and then we simplify. Negative 5 plus 3, negative 2y equals 14. Divide by negative 2, y equals negative 7. If y is negative 7, x is also negative 7, so my answer, negative 7, negative 7. Okay, that one was a little easier. Let's take a look now at 8. So 8, we've now got 6x minus 2y equals negative 12, or 4x plus y equals negative 22. Well, I can easily solve for that y, right, if I subtract 4x. I get y equals negative 4x minus 22. Now I've got one variable by itself. That's the first step. Then we say it's equal to this, so in my second equation, instead of y, I can replace it. I can substitute negative 4x minus 22. That's the second step. Third step is then to solve for x, because now I've got an equation with just x's in it, so I can solve for x. That becomes 14x, subtract 44, and we get negative 56, divided by 14, and x equals, what is that, 4? 14 times 4, 16, yeah. So that would be negative 4. Okay, that's the third step. That's half my answer. Then I take this x equals negative 4 and substitute it in the other equation, then simplify and solve for my second variable, and that is our fourth step, and then our fifth step being writing it as a point. And there's our answer. Okay, last two. So number 9, I want to solve for x by adding 3y to both sides. So it doesn't matter if I solve for x or if I solve for y. We just want to get one variable by itself. Now I can replace that x with 9 plus 3y. Then we simplify, step 3. So that becomes 10y, subtract 18, becomes equal to negative 10, divide by 10, y equals negative 1. Go back to here and say now we can figure out what x is by times it by negative 1. And we get our x is 6, our y is negative 1. That's our answer. Alright, last problem here. So I'm going to solve for this y, so I'd subtract 4x, get y equals negative 4x plus 8. Now I can replace the y with that whole piece. So 7x minus 3 times negative 4x plus 8. Remember, because you're doing a lot of distribution property, remember that minus 3 is like a negative 3. So it's going to affect our answers when we multiply. 7x and 12x is 19x. Add 24. We get negative 9, positive 19, right? Divide by 19. x equals 1. We can plug now in the number for x, and we get positive 4 equals y. So 1, 4 is where they intersect. So there we go, guys. So this is just another way to solve systems of equations. Okay, so now we know 2. So with systems, we know we can either graph them and find out where they intersect, and that's our answer, or we can use substitution where we don't have to graph. We just take and solve them out the way we've been doing, and we find where they intersect, and there we go.